All right, now it's recording. All right. Well, hopefully the technical problems are better. I have no idea what caused the stupid echo. Something to do with my USB stuff that used to work has now quit working for some reason. Anyway, USB is pretty miserable. It tends to do stupid things like this. Anyway, NPM is Node Package Manager. It's like the package manager that you use for Python. And somebody managed to stick a bunch of malicious packages inside there. So they caught 2 of them, and the developer had 4 of them in there, and they were stealing data from the users. So it is a increasingly common thing to worry about, that if you use many of these modern software products, you're downloading libraries that are pretty poorly controlled, and people can put malicious stuff in them. So it's a supply chain weakness, and a lot of people are worried about it. Anyway, let me get down to the official stuff here. Get rid of all this. All right, so we're here at 126, and today I want to talk about recognizing C code constructs in assembly, which is pretty simple. And then I'm going to demonstrate the new project, which is DIL hijacking, which is not very difficult, and it's mostly just a way to practice with these tools and see how to control Windows internals. Anyway, so I got some slides, but I'm going to mostly demonstrate this stuff. All right, this looks like something weird's going on. All right, chapter 6. There we are. Okay, so the point is you need to learn how to recognize C constructs in assembly, and I've updated these slides to match the layout required for C++ in the Flare VM, and that's where I'm going to demonstrate it. So here's the Flare VM, and we'll get to this one. The first one I want to do is, let me just get this junk out of the way. All right, print.cpp. So if I notepad, print. All right, so here's a program that does almost nothing. It uses IO, and then it just prints, but instead of just printing hello, it prints 2 and hello and puts them in with a format string. And the point of that is just, you can see that there are 3 arguments. So if we look at this in IDA, and so here it is, print.exe. And I say, okay, now in IDA 7, there is a weird thing that it doesn't show you the strings by default, and they aren't anywhere in the menu, which I was unaware of, and I had to look it up. The solution is Shift F12 for some ridiculous reason. Like, I want to see here's the fundamental problem, which I mentioned before. When it loads here, which is some kind of early Windows function to prepare the environment. It's not the code I want to see. And you can hunt around, and it's very hard to find the code you want to see. So what I do, now I wonder if the start would get you there. No, see, the start gets you here, but this is some kind of boilerplate created by Windows. So the way I know to find anything good is to start from strings. But in this version of IDA, for some reason, the strings are not in the Windows and they're not in the view. So anyway, I looked up online and it said Shift F12. Or Shift F12 shows you the strings. And the first string is a good string that says hello. So if I double click the first string, I'll get to code that's actually interesting. Here's the hello stored, and here's the xref. So if I double click that, now I get to the code that actually uses it. And this C program does nothing other than call a print routine. And the only thing worth seeing about it here is that the arguments go out of order. So the print that I used was, in fact, I can bring it up here. If I can hit the right key. All right, here's the C code that I'm using. And so I print the format string and then a 2 and then hello. So you push the pointer to hello, you push the 2, and then you push an offset to this string, %d, %s, \n. And then you call the subroutine. So this is how the function calls work in C. So when this subroutine starts, it will just look on the stack and assume it's going to find some variables. And the one that's right on top will be the first string. And what it'll do is it'll read the first one and then decide how many more to read off the stack. So print is the special function that can have a variable number of arguments. So when it reads the format string, it'll count these percents and then read that many more. So anyway, that's how it works. And so what you're spotting in that one is just a function call. So I'm not going to save this. And then let's go on to, I have to move junk out of my way. All right. So let's talk about global and local variables. And for that, I've got one here called var, which is already open. All right. So here, I've got another simple C program. And here I define, you can define a variable out here outside any function. And if you do, it's a global variable. It will be available to every function in your program. So that's a global variable. It gets stored directly in the data segment, not in the code segment. And if you are inside a function like main and you define a variable, that's a local variable, and that gets stored on the stack because that variable only exists while you're in this function. And when you leave, it's thrown away. So it's temporary and stored just in a stack frame because when you enter a function, it creates a stack frame, reserving some room on the stack for these local variables. And when you leave, it throws it away. And so down here, I have a printf with a format string and then two variables, first a global and then a local. And the point of this is we can see how those are handled in IDA. So let's look at that one in IDA. And it's right here, vars. All right. Say, okay, all right, now there might be a better way to do it, but like I say, the only way I know how to do it, I found one way that works and then lost interest. Shift F12 to get the strings. And right here is the %D. So I double click the first one. And now I see where a string is stored that I'm using. And I can double click that. And now I've got the code that uses a string. So I've managed to find the interesting code. So this is the function preamble that creates the stack frame. And then, so this is what stores the original base pointer from the calling program and moves the stack pointer, the new base pointer, to the current stack pointer. So it will now begin storing things on top, and then it's going to use pushes to make it bigger. So now, here it's going to take 3 and put it in something. Let me get my source code again. All right. So here I have int I equals 3. That's what this is. It takes 3 and it puts it in a variable, and this variable is on the stack. It's the base pointer plus var 4. It pushed ECX on, so it made some room, and now it just writes 3 into there. Now it's going to move 3 into this location on the stack, then it's going to move that back into EAX and push it. Notice this sort of funny arrangement here, which you're really going to see more of as we move to ARM. You would think I could just put 3 on the stack. What I'm trying to do is just push a 3 on the stack so I can call print. But you don't, but you want to also save it very locally in the variable and then move it into EAX and then push EAX. And I suppose you can't push this directly on the stack because that command does not exist. You must move it into a register and then push the register on the stack. And this is very common in ARM. Everything takes several steps because you can only do any kind of math in registers. So if you want to add 2 numbers, you put number 1 in a register, you put number 2 in another register, you add the registers, then you take the result and put it back in memory. So it's a lot of flipping back and forth to get anything done. Anyway, so now I've managed to put the 3 on the stack. And all right. And now I've got, so I'm working from the right. The thing on the right is I, which is the local variable 3. Now I load dword for 418,000. This is at 401,000, where Windows programs almost always load. So this is the text section. This is going to be a data segment. So it's loading from a data segment, a variable, and pushing that on the stack. That is this number G, which is a number stored outside every routine, a global variable, and you can tell the difference. Local variables are calculated on the stack somewhere. They're some number of bytes away from ESP or EBP. The global variables refer to a data segment. And then I push the offset to this string on there, a pointer to that. So now I'm ready to call the subroutine that's going to do printing. So that's all I wanted to show you there. And I think we'll go back to the slides. I'm just looking at the chat and there's no questions. All right. So anyway, that's calling functions, and then you can do arithmetic. You can assign local variables and then add them, subtract them, multiply them, turn them into floating points, and it looks pretty simple. This puts 3 in a local variable on the stack. This puts 6. This adds the contents of one local variable into a register and then puts that register back on the stack. And here you do a subtraction. Here's an integer multiply. And here's a floating point multiply. So you can make floating point numbers. There are a whole series of floating point registers, these XMMs, and you can then do floating point operations on them, like floating point multiplication and division and such. So that's what they look like in assembler. They're not really all that different than they look in C. And another important thing to note is an if. So here I have integer I equals 3. If I greater than 0, print something else, print something else. So you have a block of code here, which will put 3 in some variable and compare 0 to the contents of a variable there. So that's I equals 3. This is the comparison. After you do a compare, you can then do a jump. But if you did an absolute jump, it wouldn't do an if. It's the jump less than or equal that does it. You have jump greater than, jump less than, jump 0, jump. There are different combinations. So it's going to do this comparison of this number to 0. And if this number is less than or equal to 0, then it will go here and print it's not positive. That's the green arrow if this is true, which means the first one is less than or equal to the second element, or it goes here. So you always see this structure when you have a block that ends with a conditional jump and a red and a green arrow, then that's an if. And when you're done, you have this structure here where they're both going to go to the same place. One of these is going to jump over the other to get there, and the other is just going to have it flow naturally, but they'll both end up converging to the same code after this. And then you got for loops. So here's for I equals 0, I less than 100, I plus plus, so this will count from 0 up through 99. There's quite a few components. You define a variable, you initialize the variable to a value, then you have a comparison, and then you have an increment. And then you have an execute here. So it assigns the variable a value, compares it to see if it's time to leave. If it's not time to leave yet, it executes this and increments the variable. And I'm not quite sure whether it does the increment first and execute or the other way. But we can see exactly what happens if you look at the assembler. So here's the initialization. It defines a local variable on the stack, calculating from the base pointer, loads it with 0. Now, here's the increment, where it's going to add 1 to it. So it takes the variable, puts it in a register, adds 1 to the register, and puts it back on the stack. That 3-step process I was talking about before, because apparently you don't have an increment directly in memory operation available. And then down, and it's not going to do the increment until later. You see, it jumped over this for now, jumped down here. So it's going to do the compare. So it initializes the variable, then it compares it to 100. 64 hex is 100 in decimal. And if this number is greater than or equal to 100, then we're done, and we're going to jump off this page. If it's not greater than or equal, then we follow through, and here we do the print, calling printf. And then it jumps back to D. So the assembler has made things a little funny here. It skips over this the first time, flows through here, and only goes back there. But the point is, it's only going to do the increment if it's after it does the print. So that's what a for loop looks like. All right. And then there are arrays. You can define an array and put a whole bunch of numbers in there. This is a global array. This is a local array. And then I assign in a loop, I assign variables to the local and the global array. So here I've got initializing the local array on the stack. Then I'm going to jump down here and I'm going to compare it to 5 because I'm doing a loop. And then here I'm going to assign values to other variables on the stack. And here I'm going to assign data to variables in the data segment, dword. And I have an array there. One real fast way to spot an array is this construction. You have a base pointer and then counter times 4. One of the registers, often ESI, but it could be others, times 4, because you're typically putting in 32-bit words, and that's 4 bytes. So you have a series of write operations to one address, then that address plus 4, that address plus 8, and you typically do it this way. So you can have a loop on one register and just increment or decrement that register until it hits the end of the loop. All right, so that's the kind of stuff you see there. And that's the point. So to find code in IDA, my procedure is to first find strings and then use cross-references to make it back to the code. The simplest way to find the interesting code. Function calls, the arguments are pushed on the stack in reverse order, and then you have a call. Global variables are in memory, available for all functions, and they are in the data section. Local variables are on the stack, and they're only available while you're inside that function, in its stack frame. Arithmetic, you put your variables in the register, then you perform your math on the registers, add, subtract, divide, integer divide, floating point divide, or whatever, and then put it back in the variables. Branching, you do a compare or a test, and then some kind of conditional jump. All right, so I've got some cahoots about this stuff. And this is 126, chapter 6. All right. There and 24 there, probably a few more coming, all right? All right. Oh, we're losing people. Maybe having technical problems too. I'll give it a few more seconds. All right. All right, what kind of variable is stored on the stack? All right, those are local variables, good, because they're for temporary storage. All right, what C construct is 3 boxes connected by arrows? That's an if. All right. And what C construct is several pushes followed by a call? That's function invocation. All right, and what construct looks like that? D word and then a number. That's a global variable pointing to some other address. All right, so, all right. Those might be names. X might be the one that's not a real name, or maybe it is a real name. Anyway, so I just want to demonstrate the new project, I think. Yeah, GG, all right, good. I see you. All right. All right. Anyway, so let me point out the new project for this thing, which is here, DIL hijacking. This is a pretty simple activity, but it does give you practice in a lot of these tools we've been talking about. So if you have a Linux machine, you can install Metasploit on there and use that, because we're going to make a malicious DIL and use it to take over the box, or really to gain persistence in the box. So the point of this is you already have root on the machine, but you want to put in a Trojan that will give you constant remote control over the machine. So this is a post-exploitation activity for it's a way to gain persistence, which is one of the steps if you look at the attack matrix, one of the steps as you penetrate a system. So I realized some students might not have anything except this one Windows machine, so you can install Metasploit locally, but you do have to do it from the command line because they haven't got their Windows installer working very well. This is universal in my experience. All the open source developers that are Linux oriented never can really keep up in Microsoft very well, so all their installers don't work too well. Anyway, but if you install it from an elevated command prompt, then it will run well enough. And then you can create a malicious DIL, and if you use the help messages for these commands, you can see how it works if you haven't used Metasploit before. MSF Venom is the particular part of Metasploit that makes malicious executables, Trojan program essentially, and you can make executables or code for any language. And what we're going to make here is a DIL. So this is going to make a Windows library, and I'm going to call it shellbind.dil, and it's going to choose this attack. Metasploit has hundreds of attacks, and this is one of the simplest ones. This will just start listening on port 4444, which is the default. And if you can connect to it, then you have a command shell that will let you execute commands on the machine. It's just one of the simplest kinds of attack. Now, this is a really weak attack, not enormously useful to attack real companies, because it just starts listening on a funny port, and any company that is even slightly secure will have a firewall that doesn't let any traffic come in on unexpected ports. And indeed, a Windows machine will even block it by default, so you have to turn off your firewall, which I've already done. Anyway, then we're going to use this thing. I found a tutorial showing this, and this is a nice, easy way to see how DILs work. Distributed Transaction Coordinator. I'm going to move this to the side and get in my machine and do it live. Let me just, I'd like to move this. There we go. All right. So let's get rid of that. And all right, we're not going to use IDA or write any C code for this one. All right. So the first thing I want to do is look at services. So you get used to some Windows internals. All right. So this is Microsoft's services tool, and this shows you all the things that are running. And most of them are things Microsoft wrote. And the one that we're going to mess with is the Distributed Transaction Coordinator. So you find it on the list. And the point is this, you ought to take a look at it, and you can see a couple of things. One is if I had just freshly restarted the machine, which I guess I haven't, this would in fact have already started. And you can see here, it describes you what it is. And what this does is it coordinates transactions across things like databases. So unless your machine is a database server, this service is probably not used. And this is what you want. The idea is you have control of the machine, but you want to put a permanent client on there so you maintain permanent control. So you want to find some process that is not very important and hijack it. Something they're not actually using, so they won't notice if I mess it up. And this looks like a pretty good thing that starts automatically and that is not important. So no one's going to care if I break it. Then I go to properties, and you can see how this thing works. And you can see that it logs on as a network service, which is kind of funny. When I tried it before, it logged on as system, which I think is what it's going to do. Anyway, like I say, I just In fact, I'm just going to restart this to try to get it back to normal, because one thing to be aware is you kind of mess up your machine by doing this. You end up with something that will automatically start every time it starts, and then try to start a network process, which sort of freezes the startup process partway through. So it's a little bit difficult to remove when you're done. It's like a lot of the projects in this class. It's running a sort of malicious activity. It's not really rotten, like it's going to spread and infect other machines, but it's just a little hard to get off. So let's see if I restart and get back to it being in a clean state. So services, and G should get me down to the Ds, and then distributed transaction coordinator. Yeah, now I'm back to what I wanted you to see. It's running. It automatically started without me doing anything, and it has information about it here. And if I go to properties, then it's going to show me, you're still showing me network service. Huh? I thought I saw system before. Anyway, I think we're going to end up with system when we're done here. You'll see what happens. It may be that I was unable to entirely restore it to its original state. That one said network service. All right, that's okay to be network service then, apparently. All right, so now let's take a look at process monitor. So we start process monitor. ProCM, good old process monitor we've used before, and it's very good to get good at using this thing. So I want to find this. You know how to put in these things. I'm going to process name of MSDTC and a path ending with DIL. I'm going to remove this and put it back in just to make sure I've shown you how to do it. So I wanted a process name contains MSDTC. That'll work. It's already there. So you just choose on these menus some way to filter it. So I'm going to look at that Microsoft Distributed Transaction Coordinator and add that. And then when I say OK, this thing is now running. Now, remember, you can't let this thing run too long because it's connected to Windows Event Viewer, and it's getting a ridiculous number of events. Like it's already up to 180,000 events. They're all being removed, though, because I'm looking only for ones that match that pattern. All right, and now I want to start the Distributed Transaction Coordinator. So let's see, I might have closed my service window. Looks like I did. Got to open it again. So I just want to see what happens when I launch this service. And it looks like it was not stopped, so I'm going to stop it. Distributed Transaction Coordinator. I'm going to stop it. And when I stop it, there are some events that are associated with stopping it. And I'm going to just clean those out. There aren't too many, but anyway, you can stop it sniffing here, and you can clean it here. I'm going to leave it sniffing, but clean the old stuff. All right, and now I'm going to start this service. Okay, so these are all the activities that service did while starting. So now I'm going to stop sniffing by clicking the magnifying glass. So this number stops going up. And now I can look through here and see what happened. These are all various DILs. And as you can see, it loads various Windows DILs like Olay auth and sechost and so on. And they mostly work. But if you go down here and look for things that failed, you will find that one of these DILs did in fact fail. And file lock there, name not found. There. This thing, OCI.dil, that's where all the rest are, see Windows System 32, it's not found. And this is a little mistake Microsoft made, apparently. This is a DIL that is needed by this process, but it's not included in Windows 10. It's only in the server versions. So this is really nice for us. It tries to load a DIL, but the DIL is not there. So all we have to do is put our malicious DIL there, and it will load that DIL automatically when it starts the machine. And I'm not apparently breaking anything, because apparently the way Microsoft made it, it's okay for this DIL to fail, and the process runs without whatever that DIL is for. So all I got to do is put it there. So, all right. And by the way, you can see what happened here if you look at Process Explorer. The service has been started, and you can see what the service looks like here. Yes, still launching. No, it's here. All right. So Now remember how Process Explorer works. You've got the order in which things start up here. So you have the boot up, and you have all the things that launch before you log in up here in the pink, and then you have Win login, and down here is the stuff on your desktop that's launched after you log in. And this is a service that launches before you log in, so it's up here someplace. MSDTC. And I found it. There it is, right there, MSDTC. So it's just a single process running. And if you go here, I wonder if I can make this bigger. Let's see. Options. Font. Oh, good. All right. Let's choose my good mixture of Lucida. Bold. 16. Much better. All right. So I'll have to, of course, make the columns bigger because my font is bigger. But now, there we are. MSDTC is here up in the pink. Here's when I logged in, and everything below that is on my desktop. It's a process owned by me and running with the credentials I logged in with. But here, this is thing launched before, MSDTC. And if you want to see what DILs it uses, you click on it, and then you go to View, Show Lower Pane, and View Lower Pane DILs. And then it will show you the libraries it's using down here. And you can sort them, and by default, they're sorted by name. So I can look for that one. It was O something. OCI was the name of that DIL that was missing. And as you see, I got the M's and the N's and the O's. And there's a couple of O's, but there is no OCI because remember, it tried to load that library and it couldn't. That library does not exist. Now, apparently, this is not fatal because the process did launch, but it tried to launch and it wasn't there. So if I add the library, it'll load for me. So all you have to do is copy that. So I can go here, and the simplest thing is work from an elevated command prompt. So I right-click the command prompt and run as administrator, and then approve the elevation. And now I would like to copy something into the DIL. But in order to do that, it's good to stop the process first because the process is trying to use it. So it will lock it, I think. That's what I found before. So I do net stop MSDTC. I could stop it in the services GUI too, but I might as well do it here in the command line since it's easier. So now it's going to stop it. And you notice there was some action here. All that stuff turned red and vanished. That's what Process Explorer shows when something stops. So it's gone now. And now I can go here. I'm going to go to where I created that malicious DIL by using MSF Venom. It's this command that I talked about earlier. You create it here, there. You run MSF Venom and you create it here, and that went into my downloads folder. So maybe I won't go there, I'll just work from where I am now. So I can copy from there, C:\users, and then my name is IE user, and it's in my downloads folder. And the name of the thing I made was shellbind. Okay, there's my DIL. And I want to copy it to here, and I want to give it the name that that process expects it to be, which is OCI.dil. So it's OCI.dil. One thing that irritated me for a while, if you have the service still running, it will tell you it's copied, but it's not there, which is pretty rude. So one thing I like to do is make sure it's really there. Windows does lie to you now and then. OCI star.star. There is now a thing called OCI DIL there. Good. Now, now I can, we've done that. So I think now all I got to do is start it. And I can start it the same way I stopped it here. I can do net start. And if you do this, you'll see sort of why it fouls up your machine. If I start it here, it loads, and then some part of it is taking forever and is never going to finish loading. So that malicious, and I think what's going on is that malicious DIL doesn't actually have any exported functions. So it loads the DIL, but it's trying to load the functions and not finding them, but it worked. If you look here, you'll see there it is. And now this thing has a child that it didn't used to have, which is rundil32. And if you look at the child here, rundil32, or I guess the parent is where it is, the parent is going to have that OCI in it now. Now it has loaded the DIL. And what Metasploit does, I'm pretty sure, although I haven't taken a look in IDA Pro to make sure, is it puts all the malicious code in DIL name, which is the code that automatically loads when you first load a DIL. So the malicious code has run, and you can tell because if I open another command prompt here, I guess I can use the same one. Oh, this one's busy. So I'm going to open another administrator command prompt. And you can see if it's listening with netstat -an. And if I pipe to more, that might work. Yeah, so you see 4044 is listening. And that's what this thing does. It's listening on that port. So you can connect from this machine or from any other machine on your network. You can do netcat to your machine's address, like this one, 001. And then on port 4444. And now I have a command prompt, of course, but I see who I am. I am network service, although before I was system, so that's a little disturbing. But when I first did it, I was system. When I tried to clean it off and do it again, it seemed to demote to network service. So there's a little bug here. But anyway, so I've got my remote control. Anyway, that's all you have to do for this one. And anyway, it's hard to clean off. So let me show you how I've been cleaning it off, which is not entirely perfect. I think I'm going to add a step where you make it back to run as system again. So now the problem is I can't stop the service. If I try to stop the service, it's going to block me. And see here, might be able to do it because I logged off here in an orderly way. But anyway, the best way I found to do it is use Resource Monitor, which is another tool you should know in your Windows. Not Resource Hacker, but Resource Monitor. There. Resource Monitor is a wonderful Microsoft tool that lets you see what's going on your machine. And if you go to the Network tab, there's a listening port section, and you can just scan through the ports and see if it's listening on a port 4444. And it's not anymore because it stopped. But if it were listening on 4444, I could find the PID here and then kill it in Task Manager. This is an old trick you should know. Right-click this, launch Task Manager. And now, if you go to the Details tab, you have the PIDs, and you can kill anything you like here. And this is often what you have to do when you have some malicious process running. So in this case, it's already stopped that. So I can stop this service with, all right, I see, I'm gonna just go to my other window where I think it's already going. All right, so it's trying to do something here. Now I might be able to stop it. I'll try Control-C. Okay, and I would like to stop that service. But I think what I'm gonna find is I've somehow frozen that service in a half-dead state. Yep, it's starting or stopping. See, since it wasn't really able to load all the way, it wasn't able to stop all the way. So what I find is if I restart, and now put in my password. All right, now I should be able to kill that process by doing that procedure I was talking about. So I start with Resource Monitor. And I look for port 4444. And there it is. Whoops, thing, all right, come back on me. 4444, okay. So there it is, it's 3788 is the process ID. So I go to Task Manager and I find 3788, which is here, rundil 32. I can end that task. And now that I've done that, I should be able to stop the process with a net stop MSDTS, right? DT what? DTC, okay. All right, good. It's not running. And so now I can get rid of that dill. If I just delete OCI.dill. All right. And now if I restart it again, it should get back to normal. Although I'm thinking to get it really back to normal, I'm then going to have to go in properties and restore it to start as system again, because somehow this process of trying to start a network Trojan and having it foul up partway through the network Trojan confuses it. And now it wants to launch as network service or something. So let's go. Anyway, I might work on this one a little more. But anyway, it gives you a little practice with these things. And so now it should be back to normal surfaces, or close to normal. And it was, what's the name of this thing? Distributed network something. Distributed transaction coordinator. And it is now running. If I go to properties, it is a network service, not the local system account, which is kind of funny. Before I got system. Anyway, all right. Anyway, that's what I wanted to show you. It looks like there's a little detail here that I haven't quite got worked out yet. I may be editing the project a little bit. But anyway, go ahead and do that one if you like. And I think I'll end this video and just stick around to answer questions. If I can figure out where my control bar has gone to. Here it is. All right. Good.